Hey everybody, Ugly Shader here with another YouTube video tutorial. And as you probably read in the title, today we're going to be converting some rectangular coordinates to polar coordinates. Now, as far as what that even is or why we should care, well, it's actually really useful if you like procedurally generated textures. If you like to produce your own textures and materials, it can be incredibly helpful to be able to convert your coordinates from rectangular to polar. And basically, our rectangular coordinates are what we normally work with here in Blender. We got our X, Y, Z, left, right, forward, back, up, and down. Now, unfortunately, because images, the materials we use technically are just two-dimensional images, that doesn't always work very well for properly illustrating our materials on rounded objects. Now, this all came about because somebody in one of the Blender groups I'm in, as always, that seems to be how these come about, but somebody in one of the Blender groups I'm in decided that they wanted to produce a texture, a procedural texture for an eyeball. And they'd looked around, they couldn't find any textures that they really liked for an eyeball, and they wanted to make their own. And I was like, well, yeah, I'll help you with that. I'm sure I can help you figure that out. And we actually started a quick little lesson or whatnot. And I realized in a big hurry that I hadn't really ever tried to make an eyeball. And there was a particular problem I was encountering, and it was that the texture wasn't really appearing exactly how I wanted it. And we'll go ahead and give you an example of that right now. All I've done in this scene, it's a completely empty scene, and I've just added a sphere and then subdivided it a few times so that it was, a higher resolution and turned on smooth shading. Still not that high of resolution. We can, still see a bit of shape to it, the faces, but that doesn't really matter for what we're doing. Now, let's get a material on this thing. Drag that over and get rid of these menus. Actually, before I get rid of that menu, let's start some screencast keys. There we go. Now let's switch this one over to our node editor. And you know what? We should come back over here, switch that over to rendered view, and add us a light so that we can actually see what's going on. Oh, my bad, not a spotlight. I want a sun lamp. And I'm just going to rotate that a bit on the X and then some on the Z and bring it around so we can see it all nice and bright right here. And while we're at it, let's brighten up our world and make it something a little softer on the eyes. There we go. So here's our sphere. I guess I can add a plane for reference so that we know where, like up and down and stuff like that is. So there's a plane for reference. We even got a nice shadow on it. Anyway, so this sphere, the first thing I was going to help the gentleman with was blood vessels. I was like, all right, well, we need blood vessels that, like stretch from all around the eye up towards a center point. And I was like, oh, that should be easy. Let's just grab us a texture and let's grab a wave texture real fast and plug that in. And I was like, okay, well, I kind of got my, lines, but, they're not exactly stretching from like a pupil outward. They're just rings around the sphere itself. And I was like, oh, I know. Let's just throw a mapping node in here and come in here and let's adjust this rotation. And I was like, I'll bring this rotation around. And I was like, well, wait a second. I don't have bands. That just rotated where the texture was appearing. Oh, I must be on the wrong rotation. And then I started playing with my other rotations. I'm like, all right, this is literally just moving my bands around. That's not what I want. Oh, that's right. It's going to be location that'll affect this for me. So let's start adjusting that location. And I was like, well, wait a second. Well, now how do I get bands? And I started putting together a whole bunch of weird mixtures of nodes all piled up trying to get my bands before I realized that, well, you know what? If I could illustrate this texture on this round object like this object was a globe instead of a cube, this would go a whole lot faster and be a lot easier. And that's what this video is about. We're going to take these X, Y, Z coordinates, and actually we're just going to use the X and the Y because, no matter what object and how three-dimensional our object is, the image itself that we are producing for a texture is still two-dimensional. So we're only going to use x and y, but we're going to turn that x and y into magnitude and angle so that we can actually apply that material to this object like it were a globe. So let's go ahead and do that. And we'll keep that there. And, scoot that back down. We'll just scoot these over, and we're going to scoot them quite a ways over because we need to do, watch out, bad word coming. We need to do math in order to convert this from one to the other. And you know what? It's not that bad of math. I actually put together a little image here. I'll throw this down in the comments or whatnot so that you guys could just make note of it. And yeah, we just have two different equations to worry about. Our magnitude is going to be well, actually this is backwards. I'm going to do a y squared plus x squared. Oh wait, no, this one's fine. Yeah, we're going to do x squared plus y squared. And then we're going to, just add our x squared and our y squared together and then find out what their square root is. That one's super simple. This one's actually really, really simple too. We're just going to divide y by x. Basically, find a simple slope value out of them. And then we're going to feed that slope, or find basically the arctangent of that slope to convert that into an angle. Unfortunately, it's going to pop out in radians, and because of how we use it in the equation, we're actually going to bust it back down closer to a 0 to 1 value. So we'll take the answer from that and divide it by half of pi. And honestly, this right here looks a lot more complex than what we're going to be doing. And don't worry, I'll go ahead and explain it every step of the way so that you actually get what we're doing instead of just see how it's built. Those of you who have watched some of my tutorials have probably come to notice that I'm a real big fan of explaining everything I do because I think you should be able to understand the nodes. I don't do these tutorials just to show you how to build something. I'm trying to teach you how to build it, and hopefully you can take what you've learned from me and expand upon it and start making things even more complex than I showed you or that I could even imagine. That's the whole fun behind all of this, right? Anyhow, so what we're going to do is we're going to take the coordinates coming out of this mapping node. Woo! Jumped a bit there. And we're going to change them from the rectangular coordinates to polar coordinates before they make it to this wave texture. All right, well, the first thing we're going to need to do is separate these out. So we're going to come into our converter and we're going to grab a separate XYZ. And we're just going to drop that in there and separate them out. And as I said, we're actually not going to be using the Z. We're just going to be using X and Y. And through X and Y, we will manipulate both of them with math to produce an angle and a magnitude value outward. Actually, we're going to do magnitude first, then we'll do angle. Well, first thing we need to do is, by nature, let's grab a math node and drop it in here, and I'll explain what we're going to do. Now, by nature, this is coming out technically kind of on a 0 to 1 value. But we don't want a 0 to 1 value. We want a value that can go as far positive as it can negative. I don't know if that really makes sense, but basically instead of a 0 to 1 value, we want a negative 0.5 to a positive 0.5. The size of our value from smallest to largest is still a value of 1. However, instead of 0 to 1, we've just stepped it down by 0.5 so that we can go just as far onto the negative side of things as we can into the positive. And to do that, we just take our 0 to 1 value, basically, and then subtract 0.5 from it. So now instead of 0 to 1, it will be negative 0.5 to positive 0.5. And we are actually going to do that for both of our x and y values. Basically, you could think of it as balancing the values out. Yeah, at least just for the sake of what we need to do with them equation-wise. Now, I want to take both of these negative 0.5 to positive 0.5 values that are running through these math nodes, and I actually want to increase them from a negative 0.5 to positive 0.5 all the way up to a negative 1 to positive 1. And I can actually do that really simply just by multiplying them by 2. And yeah, the whole reason we're doing this is because we want to take basically this 0 to 1 value and turn it into a negative 1 to positive 1 value. So we still want that 0 to 1, but we also want to be able to go backwards to negative 1. And I guess this was just the easy way to figure it out. So all we have to do is take each of these and multiply them by 2, and we are done. We now have our numbers set up the way we need for our first equation, for the x squared plus y squared, and then find the square root of it. X and y are now set up the way we need them to be, so now we just have to do the math that's in this equation. Sorry, I'm looking at this on a huge screen. If you're on a little screen, that's probably hard to see. So yeah, basically we have now set up x the way we need it. It is a negative 1 to positive 1, and y is a negative 1 to positive 1. Now we just have to square each of them, or aka multiply them by themselves, and then add them together and find their square root. Now, it sounds like kind of complicated math, but again, Blender's got these handy math nodes that makes all this stuff super easy. I went over quite a lot of these nodes in the advanced mapping node tutorial I did. Anyhow, so to square these, we just have to multiply them by themselves. So I set this node to multiply, or it already was, and then I multiply this number by itself. It is now squared. Do the same thing to this one. So now x and y are both squared. Another peek at our equation. Oh, why did you lose your zoom? Says that we need x squared and y squared, and then after we've squared them, we need to add them together. Well, that's simple enough. Let's grab us another math node. Add these two together, and we'll switch that to add. Now they are added together. And you see a bunch of stuff changing and happening over here that's not exactly what we want, but that's just because we're not done yet. Anyhow, so there we go. They've added back together. Now the only last part of that equation for us was that after we had x squared and y squared, and then we added them together, we needed to find their square root, the square root of all of this stuff put together. Now, unfortunately, Blender doesn't have a square root node in its lineup. However, it has something just as efficient. Another way to find the square root of something is to multiply it by the power of 0.5. 9 to the power of 0.5 will be 3. 81 to the power of 0.5 will be 9, so on and so forth. All you have to do to find the square root of something is multiply it by the power of 0.5. So there we go. There's our square root. That is done. That is converting our x and y into our magnitude. And now, mind you, this right here was just to balance them, to take them from a only positive number to a number that could be positive and negative. And then this was just to increase that positive to negative range. So these don't actually count as part of our equation. That's just our equation. These were just to make sure we started with the numbers that we wanted to start with. So yeah, really simple math when you get right down to it. And because we're going to have magnitude and an angle coming out of this, we're going to need to combine them back together before we send them into the vector. Now, instead of using combine XYZ node, I'm actually going to go ahead and use a combine RGB node. And that's so that I can make sure that they still have some form of data that Blender will read as color as it goes back into the vector here. Because Blender communicates its information, its vector information with colors. And I'm not 100% sure if it messes it up, but there's a possibility that if I use just a combine XYZ, it's not going to assign the proper technically black-white values that I want going back into the vector. So yeah, I'm going to go ahead and use a combine RGB node to mix these together. So we have our magnitude done, and I mean technically you could name that, like if we made a group out of it and everything, we could name the outputs, but for this, we might not. I might go ahead and make a group out of it right at the end. This should be a fairly quick video compared to my normal ones. Alright, so there we have it. We have our magnitude. Now we need to get our angle set up. Now just bring this down. Actually, I don't need to bring that down a little bit. See, now for our angle setup, we're still going to want to use a little bit of this first stuff that we did. For doing the calculations on our angle setup to find our simple slope, basically, it's just going to be y divided by x. But again, I don't want a 0 to 1 range when determining these values. I want a range that can go just as far positive as it can negative. However, I don't need to double it all the way up to a 1 to 1 range. I can just use these first subtract nodes here and go ahead and just use the negative 0.5 to positive 0.5 range to find my slope. So just let's look at that equation real quick. I wish it didn't minimize that every time. All right, so what we need to do is we need to find y divided by x, and then we need to find the arctangent of y divided by x. Basically, y divided by x is going to give us a simple slope, and then we can use arctangent to determine its angle in radians. So let's go back to Blender, and let's start with the first part, the y divided by x. So we need ourselves a divide node. And like I said, we don't want to take this again straight off of x and y. We want to take it off of our balanced versions of x and y. So instead of 0 to 1, we want that negative and positive scale that we produced by subtracting it by 0.5. So we're going to take y and divide it by x. So y is our bottom value right here, y. So we plug that into the top of this node and divide y by x. Honestly, because it's just two-dimensional, it'll probably work both ways. But just to be on the safe side, go ahead and do y divided by x. Now the next thing we needed to do was to find the arctangent of that. So let's go up to arctan. And we don't have to worry about what this bottom value is. The default of 0.5 is fine, 100 is fine. It doesn't really matter because sine, cosine, tangent, arcsine, arccosine, arctangent, they're just a way of processing a single value and determining something else from it. So this bottom value isn't really regarded. There may be a situation in which you can use these in Blender, the tangent and cosine and sine and stuff with the bottom number. I have no idea. All I know is that by default, when you plug something into the top of this one, it just seems to ignore the bottom, which is handy. So there we go. We took our y, divided it by x, and then we found the arctangent of that. Oh, wrong one. And that means that the only thing we have left to do is divide all of that by half of pi. And the reason we're going to divide that by half of pi is we want to keep it down to that 0 to 1 range or whatnot. We're bringing it back down to a 0 to 1 range. But basically, this is sending out radians. That's what our value is coming out in. And traditionally, I'd convert that to degrees. In fact, that might be what we're doing. You know what? I put this tutorial together so fast, I kind of just rushed through the math on it. We might be converting that to degrees. Now, like if we had degrees and we wanted to convert it to radians, we'd multiply it by pi and divide it by 180. So yeah, dividing it by half of pi might be converting the radians back into degrees. I can't quite remember. Well, what's important is that it works, I guess. I don't know. I should be able to thoroughly explain why it works. Who was it? Was it Einstein that said if you can't explain it easily, you don't understand it well enough? Well, whoever said it, that's definitely the situation I'm in right now. I need to learn this stuff better. Anyhow, so what we're going to do is we're going to divide that value by half of pi. And half of pi is just going to be 1.57079. Now you could keep going further with that, but unfortunately Blender's only going to store the 5 characters past the decimal point. In fact, when I hit enter, it actually goes to 1.571 as far as what it shows us. However, if I click on it, we still have our 57079. So it's just kind of showing us a rounded version in this window. And yeah, anything past 9 doesn't store. So you only get them 5 past the decimal point. And I guess if you wanted an even more accurate version of pi, well, I guess that's as accurate as you can get it, because 3.141592 divided by 2 is the 1.57079. So yeah, that's about as accurate as you can get the half of pi. And that is going to serve as our angle. And instantly you can see we now have these lines up here at the center, and they're all stretching down around the object. Now, some of you may have noticed this little bit of seam that is running straight up and down right across this. Unfortunately, there's not a whole lot to be done about that. Basically, we're taking a flat image and trying to cleanly wrap it onto a round surface. And it does pretty good. Something we could do to make it work a little better and actually get some of this bend out of here, if we were, actually going for the eyeball, is up here. We can add ourselves a divide node. Where's divide? Right up there. And set this to 4, and we could divide the magnitude by 4, and that actually straightens this out quite a bit and does a pretty good job of hiding that seam. You get a little thin spot on each side in the line right here, which you won't notice if you manipulate this texture. And same thing on the other side. There's a little glitch up at the top and a little thin spot in the line right there. That, yeah, you just don't really notice. Well, with a lot of textures, you don't notice. Super, super detailed texture all way up close, yeah, you're probably going to notice. But again, still, this is a great way of getting a texture to work differently on a sphere, just because textures on spheres are not always the friendliest to work with. And then, like, if you've gone through the tutorial I did for the advanced mapping node, I guess I'm just going to have to append that. File, append, where is it going to be? I know I have one saved out here. I have 2 saved out here. Do I? Group, nodes, where am I going? Node tree, advanced mapping node. Let's append that thing into here. So, group, advanced mapping node. So yeah, if you've gone through my tutorial for the advanced mapping node, then actually be quite simple to start to achieve the blood vessel appearance simply by drag this out real quick, drag this out. Let's throw ourselves a color ramp in here to tighten that pattern up a little bit. Bring it, oh, no, I wanted the little tab, thank you. Get that gray out of there, make them all nice and thin. And then, of course, blood vessels aren't black, so just for the sake of appearances, let's throw mix RGB in there. Oops, and we will control the factor with that happy little node group we just put together. Make the top color red, and there we go. Now we got some red blood vessels, but blood vessels aren't all clean and pretty like that, so we're going to grab ourselves a noise texture, and we're going to feed the locations of the wave texture with the noise texture, and bring that up a little bit like that, and bring its detail up. And then, well, we wouldn't want the blood vessels running like all the way up into the center, especially all dark like that. So we just use ourselves a quick gradient texture to form a mask so that we could fade out the center right there. And I want a bit more wobbliness in my blood vessels, so let's grab another one of these advanced mapping nodes. Let's plug you into there. And I don't have, oh, I do have a texture coordinate node out here, so let's grab that. And let's give you some generated coordinates so that you're not all goofy. And on this one, let's go ahead and grab ourselves another wave texture. And yep, just like the, instead of just the location, let's go ahead and feed the location and the rotation of this guy with our wave. And then I'm going to bring the detail scale down and bring the scale itself to like 2.5. And there we go. Starting to give us some of that nice blotchy breaking out appearance to our blood vessels. Granted, that's quite a few blood vessels. Where's that original wave? Let's bring you down to about 2.5. There we go. Now again, this is something that, it's just a really, really rough draft, but there's the example that originally inspired me to figure out how to produce this node group, this converting your rectangular coordinates to polar coordinates. And again, when it comes to putting textures on spheres, it opens up a whole new set of possibilities for how you can get those textures on there and how you can make them look. One more time, we separate our coordinates. We ignore the z because we're not using z. It's a two-dimensional image. No matter how we stretch it, twist it, or build it, it's a two-dimensional image. Now, if this were for volumetrics, you would actually want a z, so perhaps I'll have to do another tutorial video where there's, the magnitude and then two angles so that we can represent three-dimensional textures with the z-axis. But yeah, for our magnitude, we balance from a 0 to 1 to a negative positive scale, and we double our scale to bring it up to the -1, +1, and then we just square them, add them together, and find their square root. Done. Oh, and yeah, we divided to take some of that curly swirliness out of it. We divided by 4 to straighten those lines out. And then we send it into a combine RGB node to feed it back into our vector. And then for our angle, we just took our balanced ones, not the balanced extended values, just the -0.5 to +0.5 that we produced here. And we divide y by x, feed it into an arctangent node to find its angle, level it out, and send it into our combine RGB. Done. That right there is all it takes to convert the rectangular to polar. Well, as always, I hope this video was helpful. I hope you managed to learn something from it. I do think I may end up doing a couple more videos for like a mini series for building like a somewhat acceptable procedural controllable eyeball. Maybe not too fancy. I might make a really, really fancy one and sell the node group for like $1 or something. It'll be intense. But yeah, I think I might do a tutorial series on a not so fancy eyeball. Something that gets you by at character face distance, maybe not super, super close up, but at an okay distance be fine. Anyhow, good luck with all the projects that y'all happen to be working on right now, and as always, enjoy creating things your way.